Good morning, everyone. Welcome to our talk about OSGi R8, Felix 7, Atomos, and the future of OSGi at Eclipse. My name is Bosschaert. I'm a senior engineer at Adobe. I'm also involved in the Apache Software Foundation, where I'm a member, and in a few PMCs. And I'm also in the OSGi working group at Eclipse. And with me here is Karl.
I'm Karl. I'm also working for Adobe, remotely from Berlin for the Basel office. As well, I'm a long-time member of the Apache Software Foundation, mostly involved with Apache Sling and Felix nowadays. And just recently became a member of the OSGi working group at Eclipse. And today, we want to start with an update on what happened to OSGi in the last year, namely that is now at Eclipse, and David will tell you a little bit more about that in a moment, and then give an update on the R8 core specification and what's happening with the Compendium specification right now. And then I will zoom into one particular spec of the R8 core called OSGi Connect, and an implementation of it that we have in Felix called Atomos, and in general give an update to what happened with Felix 7 and where we are with Java compatibility, and conclude the whole thing with a little demo of the above. And but now let's first give it up to David with the future of OSGi at Eclipse.
Thanks, Karl. Okay, so for those who haven't noticed it yet, OSGi is now an open source project at Eclipse. So it migrated from being a standalone kind of specification organization to a project at Eclipse about half a year ago. And it means that OSGi is now fully open source, and that includes spec development, TCK development. It can all be, everyone can join in and be part of that process without having to become a member like it was before. The reference implementations are now called compatible implementations. They're typically done at Eclipse or Apache or in some other open source project, as long as the license is compatible. So yeah, just really briefly, that's all there's to say about it. Anyone can join in and contribute. And if you're interested in how to do this, there's a link here where you can see more information. Okay, so let's talk about R8. And as Karl already said, OSGi R8 is really Core R8 and Compendium R8. Core R8 was already released late last year, and that contains two new specs, the Connect specification, which Karl will do a deep dive on later on, and the new condition service specification. I'll just do a brief overview of the other new specs just to give you a flavor of what they're about. So the condition service is really also known as the ready service. And a lot of people asked about a service like this that basically indicates when your system is ready. So you can print the word ready on the screen, for example, or you can open your main port to your application so people can start serving requests for end users. But when is your service really ready? That is generally quite app specific. And sometimes there are multiple levels of readiness. Like, it's not necessarily when the framework is starting up, but it's probably more like, okay, all your bundles are started, maybe your database connection is open and some third-party integration is up and running. And when all those application-specific conditions are ready, then your service is really ready. And the way that is now kind of abstracted in OSGi is that you can register a service under the condition interface with a specific identifier and say, okay, this condition is ready. And then that condition is your application-specific condition. You can listen for it in a component or any service consumer and say, okay, when this service is available, I'm going to do the last thing to really open it up to the end users. So really briefly, if you wanted to do this in declarative services, you could just have a condition reference on the condition service with a particular target. In this case, it's called my condition. If this condition is available, the service will be registered, and you can basically print the word ready on the screen. Okay, moving up to Compendium. Compendium R8 is still in the works. It is almost finished. I'd say it'll be finished probably next month. I think we're really working on the very last bits and pieces there. And there's 3 new specifications in there. The service layer for 1M to M, which is like an embedded integration specification. There's the typed event service and there's the feature service. So I'm going to talk a little bit about the last two new specs. Typed event is a little bit like event admin, but then for typed objects. So event admin in OSGi allows you to send events from one entity in the application to another. It's a local eventing service. Now, some people have implemented remote technologies on top of it, but that's kind of outside of the specification. Typed events is very much like event admin, but then you can send over typed objects rather than maps, which is what event admin allows you to do. So typed objects are typically DTOs. DTOs are data objects that contain primitive types and collections and so on, but they can also contain other DTOs. So they're really kind of structured, strongly typed objects. So quick example of how you could use this. Let's say I have this example event, which is just a class with two public fields. This is a DTO. It has a Boolean and string. If I want to send it, it's pretty simple. I obtain an event bus, and I just simply create the object and send it to the event bus by calling bus.deliver, and I can specify the topic where it needs to go to. And then receiving is equally simple. I create a component that needs to receive this event. It registers an event handler, which is a generic type. It specifies which type of events it can listen to, and then I simply get notified when the events are arriving. Okay, and then finally, before I hand it over to Karl, there's the feature service. Now, Karsten and Karl and I have talked about the feature model for many years here at adaptTo, and the good news now is that the feature model is now spec at OSGi, which is really great. It's not everything that Sling has yet, but it is really a foundational specification that allows us to build on top. And it's not modeled only on the Sling features. It's basically a combination of the ideas from Sling features, the Karaf features, the Eclipse features, and other ones. And the idea is that we have some sort of like a standard, an interoperable model that can work with all these implementations of similar technologies, like the feature service in Sling. So it's really about when you have a system that is growing larger and larger, you have a lot of bundles in there, and at a certain point, it becomes hard to remember what everything is for. Why do I have all these 500 bundles? Why do I have all these hundreds of configuration entities? And maybe you have additional metadata in other places as well. Now, if the feature model allows you to combine that in kind of chunky components that can easily be reused in different contexts without having to understand every little detail of those components, but still allow you to override parts that you want to change. So it's really a design artifact, and the feature service in OSGi currently only specifies two things. It specifies the JSON model, so you have an interoperable JSON format, and an API that allows you to create the feature model using Java and read and write this JSON model as well. So it's a building block that allows us to kind of build new authoring tools for such features, build time technology. For example, you may want to generate different side products from your features, like, for example, documentation or a database schema based on information in your features. And finally, obviously, you need a launcher to launch your feature at runtime. And here's a little example of what a feature would look like. It has an ID and a name, obviously. This one only has a few bundles. So this is like just 4 bundles, and you can see there's a little bit of custom metadata in there in my bundle list where I specified some custom documentation for my Java doc. And then finally, near the top, you can see that there's a complete attribute. And if the feature says I'm complete, it means it does not have any external dependencies. So this is like a queue for the launcher that it can launch this feature without having to kind of combine it with any other features. Right, so that's all my quick update about Core and Compendium. The Compendium spec should be finished sometime next month, I think. But you can already look at the current drafts at this link. They're basically rebuilt after every commit, so you can get the very latest and greatest there right now, and it won't change that much anymore. And with that, I'm going to hand it over to Karl, who's going to talk about OSGi Connect.
Screen here. Okay, does it look correct? I hope.
Yes, looks correct.
Okay, so OSGi Connect. Yes, really, that's I mean, from my point of view, that's the main part of the OSGi R8 core specification that we got in, and it comes back to a very old use case for OSGi, right? So typically, what you want to do with OSGi is, well, you run Java and an OSGi framework on top of it, and that is the main use case. But pretty early on, people started to embed OSGi frameworks into their applications, either as a means to have a plugin framework, or just because they were running in something bigger on the outside, like a Java-e application server. So pretty early on, we got the launching an embedding API for OSGi, which is basically gives you a framework factory, which you can use to create a framework, and then can configure it to, for example, delegate down packages from the outside into the framework via the system bundle, or boot delegate them, depends. And you can also use that API to get services out from the framework. So that works okay. It's a little manual and somewhat static, right? Because you have to create that list of packages you want to delegate down, and we don't have a way to find out what's really there, and so it's not optimal, but it worked. In Sling, you would use the Sling properties to configure these things. So that worked, but over the years, there was another use case which was not so well supported, which was that you wanted to potentially migrate your bigger application, step by step into an OSGi framework. So a while ago, I came up with a version of OSGi, which I called PortResR. I'm bad with names, as everybody knows. But that was effectively an OSGi framework without the module layer to support that use case. And Richard Hall at the time came up with a concept called virtual modules, which were another way of extending the module layer from the outside. But we never really got to turning it into a real spec. Because I guess there wasn't too much need for it at that time. But then a couple of years ago, Java with Java 9 started to introduce the JPMS, so the Java Platform Module System, which is a way to, on the one hand, modularize the JDK itself, but also a way for just normal Java applications to be modularized. So it's a real module layer, and that obviously created some tension with the OSGi framework running on top of it. Just on the one hand, implementation-wise, but also in general, what does it mean if you have a component or module on the outside, and then also want to have it be a bundle, right? What you do with that? So Tom Watson started to experiment around that a little bit to see whether we couldn't integrate that better. And then more recently, native compilation with Graal Substrate became a thing. So that also was an interesting use case, because in that case, because you do ahead of time compilation, you effectively don't have class loaders at runtime. You sort of have a class loader, but it cannot do anything. So we were really getting together and trying to look, can we support all of this in a generic way and a better way? And we thought, yes, we can. So the idea is that we basically allow bundles that bundle objects at runtime, at least, let me put it like this, that really have their content be managed outside of the framework. So while they're represented at runtime as bundles, what they load in terms of classes and resources really comes from the outside. It's something outside that manages them. And then they're just effectively connected into the framework as bundles. And so just to show that in a different light, right, you have the different layers of OSGi. You have the module layer at the bottom, and then you have the lifecycle layer on top, and then you have the service layer on top of that. So we really target to make that OSGi module layer either go away or at least be extensible. Right? To be able to work with the rest of the stack, so the lifecycle layer and the service layer, even so you really get different modules from some other system. And that's what OSGi Connect is all about. I mean, it really targets use cases to say, okay, well, what happens if I have bundles on the outside on the module pass, right? The JPM has modules, but they're also bundles. Can I use those? What are those bundles that are on the class bus? Again, that's a very old use case. But while we're at it, can we make that work better as well? And then additionally, again, one big target also was Graal and a native image. So what do we do in cases where we really don't even talk about Java bytecode that gets loaded, but something on the outside just has some other notion of a class? And that, interestingly enough, is also the case for Android, which is very similar in that regard to the native image case, because they have these kind of DEX files behind the scenes, which are not real Java bytecode. But something else. And we called it OSGi Connect. And the idea is that we really don't change that much API-wise. We piggybacked it for the most part on the install bundle call. So what happens in the normal install bundle call on the bundle context, right? You give it a string location and then a content, and the location needs to be unique and can be a URL, but doesn't have to be. And optionally, you can give us an input stream from where to load the bundle from. Okay. So, and then if you do that on a running framework, you end up that the framework actually first sees, okay, did we get content from the input stream, right? Well, in that case, use that one. If not, look at the location and see if you can, find out where the content is supposed to be. Typically, we do that by creating a URL out of it and try to load it. And then if any of the two methods succeed, we download the content, store it in the storage of the framework, typically the cache on disk, as a jar file. And then we create a bundle object for it, which represents it at runtime in the framework, and call it installed. And from there, it can go to the resolved state, which means we create a class loader for that bundle, which will load the content from the jar, as well as delegate to the right places according to the metadata that the bundle provided, import and export packages, and so on and so forth. So that's what you normally have. Now with Connect, we added a new Connect framework factory, which is similar to the framework factory you had before, just that it has a new framework method, which in addition to the configuration, now also takes its module connector. Module connector is a very thin interface that can be implemented by somebody on the outside. You typically assume that it follows the same pattern. So you would assume that there's a framework impl that provides the Connect framework factory and a module connector impl which provides module connector by ways of a service loader, for example, and a launcher that can find those two. And if it has those two together, it can create a new framework, calling new framework with the two, and it gets back a normal OSGi framework that works in all, that works like it used to. The same way, but if you get an install bundle call for a location, it will first, before it tries its normal spiel, it will try to go out and ask that module connector that it had from the beginning, can you connect that location? Do you know anything about that location? And if the module connector says no, well, then we just proceed like before. So suck it down and make it a jar in the storage. But if it does return us a connect module, then we do something differently. We will back that bundle that we create as a representation by that connect module. And the connect module interface has class loader and it has ways to load resources from it. So that way, the module connector can effectively proxy something from the outside, like a module, in this case, on the module pass, into the framework and get it represented as a bundle at runtime. And then the delegation will go to the class loader from the outside to load classes and resources for that bundle. That's the whole idea. It's It's not super much invasive in the API. And again, this module connector, we didn't spec any of those, so you can implement your own if you know what you're doing and what you have from the outside. But obviously, the idea was that you would over time get some generic module connector for these some use cases, and we created one, which is called Atomos. It's now an Apache Felix sub-project. It's based on work that Tom Watson from IBM did for the JPMS experiments he did, but now it really supports at least the common use cases that I mentioned before, the 4. So it supports JPMS. So it will connect your JPMS modules into the framework as bundles. So they can live side by side on the outside if you want to. And it will generate OSGi metadata for JPMS modules that don't have any manifest based on their module info. And that's nice because we really get the JE boot modules represented as bundles. So everybody wires to the real modules and not to the system bundle for any packages anymore. And then we also support the Java class path. That means if you have a bundle that's on the class path of the framework, it will start, pop up in the framework automatically. Obviously, you don't get the class loader isolation in that case. But the nice thing is that we can also support just any URL class loader in that case. So if you're, for example, inside a Spring Boot loader jar, that works as well. Then in the end, we also have some support for Graal Substrate, so for native images, which is a little bit more complicated because if you natively compile, the result loses the identity of where it came from. So you don't have jars of the class path, for example, anymore, or JPMS modules. You just get the compiled native image. But we have a way to create an index when you compile, so that we retain that information effectively for runtime and can then piece it back together so that it still looks like an OSGi framework in the end. It's not perfect, and it will not, automatically translate everything for you. There's still work to be done if you want to really do something complicated on Graal. But at least for the typical low-level OSGi part, it is working, and we have some Maven plugin that can help you with some other stuff. And last but not least, we also did the same thing effectively for Android, so that works up to a point as well. It's somewhat similar to the native image case, because we also have to create an index. They have a lot of the same assumptions. They assume a closed world for class loading, and the resources get decoupled from their identity. So we have to create an index to represent the runtime. But that's all working. We have examples for all of that, and I will show that in a moment. And finally, then coming to Felix 7, that's obviously where it comes all together, because Felix 7 does support the latest R8 core, and it's much improved in general with regard to Java on JPMS. So and starting with 7.01, it also works good with Java 17. And the nice thing is you don't need any add opens anymore. That still was the case for Felix 6, but for 7 we don't need any add opens anymore by default, at least for the framework itself. And it is actually a JPMS module, so it can be run from the module path itself, which is interesting, right? Because you get a JPMS module on the module path that will provide the OSGi functionality to load bundles at runtime, which are then not modules, obviously. And then again, with Atomos, you can merge the two worlds together if you want to. And I'm going to show just that right now. So if I manage to switch my screen here for that one. No, I want to go here. So, okay, I hope you can see my screen here. Close that one. Hide this one. Okay, so yeah, okay, so right. So as I said, Felix itself is now a module. So if I go and take the main Felix jar and tell jar to describe it to me as a module, you can see it actually has a module info and it exports packages and things like that. It has a main class here as well. That means I can actually put it on. I can put it on the module path and start it. So you can see framework starts up. It loads some bundles. That all works, but it was actually coming from the module path. That's kind of nice that you have that, because now what you can do if you have that working, you can use jlink to jlink yourself a platform with that framework, right? So I just tell it to add the module of Apache Felix main, and it will create me an output test which has everything to run it, right, including the JDK. So just to show that here, if I go and run the Java inside the test platform that I created, you'd see, okay, that's only based on 3 modules: the Java base, the JDK unsupported, and the Felix main. So then let's see what that means in terms of size. Well, that's all, 24 megabytes. That's the whole test that we have here. And then, so that's pretty small for Java, right? And I can actually then go and run that, what I created here. And as you can see, it starts up, but it does fail in GoGo because it's missing a class, and that's Java util logging logger. And if you noticed, we didn't include the Java util logging base module, and that's because, well, we only jlinked the framework, right? We didn't tell it about the bundle, so it couldn't know, and we didn't tell it explicitly to include logging. So of course we could go and do that now, but a much nicer way is now possible if we add Atomos. So if we add Atomos, we can actually make those bundles, give them module infos. And we have an example for that, the Atomos source code. And the examples. Here we use some tool to augment a couple of bundles with module infos, so that the end result will have actual module infos itself. So they're kind of a hybrid between modules and bundles. And then if I do use that one to jlink me a platform, well, I end up getting a little bit bigger of a thing. You can see here I have Java base. Now I have Java logging, and I have the bundles themselves and Atomos as JPMS modules. And then with that, it's a little bit bigger. It's 28 megabytes, not 24, but oh well. And I can now start that one, and I get a working system here with all the bundles coming from the JPMS module test, as well as the base modules that are in there. You see that's what Atomos generates as metadata for, like Java base and Java log. So we really get a nice blend between mix between the two worlds. So that's cool. And then let me quickly show you that this also works for the class path. So here we have an example, which is a Spring Loader jar. I don't know how much you know about Spring Boot, but I mean, typically, if you create this kind of Uber jar for Spring Boot, you get a couple of Spring classes that are used to load from it, and it will package the libraries you require in the lib folder, boot in flip. And at runtime, then it will use those on the class path without unzipping them, because they have a special URL class for it to do that. So that's really what we have here. And I can go and start that now, and it has Atomos included. So what that gives me is a working web console, I hope. Yeah, here we go. And coming from a Spring Boot jar, it didn't extract those jars. It's just there. You see here again, the JPMS modules are represented as bundles as well. But also the bundles are packaged into the Spring Boot one, which are coming from that jar, as you can see here, right? It's just the jar syntax down there because they support it. So, and it's all wired up correctly. So if we would go to the Java base here, for example, we can see that we have actually all those bundles that import from it correctly wired up. So that works. And then quickly here at the end, let me show you that you can also do the whole thing for Graal Substrate. So I created a native image ahead of time for the same example. It's here. So as you can see, it has about 34 megabytes of disk footprint, and it's just an executable. And again, let me quickly show you one more thing here. So if you go back to the Spring Loader example and start it up again, just to see, I mean, one of the main reasons why we do the native image stuff, right, is memory, right? So startup time memory. And if you can see, the Spring Boot right now takes about 200 megabytes of RAM when it's running. And now if I start up the native image, here, it's pretty quick. I mean, it certainly is quicker than the Spring Boot one. You can ignore the errors, that's fine. And I go back here and go here, it's running. So this is running from a native image. Again, we present all the bundles, they are wired up and they're here and are mostly working. Again, the actual functionality might need some tweaking, but at least for the main part, it's working. It has Jetty and everything in the web console working here from a native image. And the nice thing about it is, so I mean, if you now look at the memory here, for it, you can see that is around 35 megabytes. So that's certainly a lot smaller memory consumption wise. And again, I cannot easily show that here, but it started up a lot quicker as well. So for certain use cases, at least you can do native compilation then with the system. Again, I mean, for the actual application, you have to do more because there's no reflection information in the native image. So you have to give it hints for the parts of the application that needs to use reflection at runtime. Otherwise, it will fail. So, for example, here, I mean, not everything here will work without errors because we would have to first make sure that all the reflections is working. But at least you can now turn your OSGi application into a native image. Right. So, and I guess with that, I'll go back to my slides, or at least to the presentation. So that's it. That's the things you can do with Atomos and Apache Felix.
Thanks, Karl. There are a couple of questions on the Q&A pod that are probably good for you to answer. The first one is from Robert. What extra libraries does a jlink image require?
Okay, so that's probably a question about embedding it into a container. Yeah, I see it. Yeah, okay. So yeah, I mean the jlink. I mean the result of a jlink still needs whatever you need for a normal JVM, right? Outside of it, right? It contains the JVM part and all libraries, but yes, you will need a libc and an operating system. So you cannot put it into a from scratch image. That's technically a little bit more interesting with native image because nowadays you can put the native image into from scratch. So basically, you would end up with a Docker image, which is not much bigger than the actual native executable. So that's the main difference here. We saw the result was about 34 megabytes on disk. So if you probably end up with a Docker image roughly around that size, versus for the jlink image that was 28, I would assume you end up with about 50 megabytes because you still have the operating system. We did something like that with Radu a while ago. I think two adapters ago. And then we have Jörg with when can we expect a working Sling on a native image? I'm not talking about AEM right now. Well, so the good news is I at one point of time with the predecessor, the PostgreSQL stuff, I actually had a hacked up AEM running on PostgreSQL. So it's not completely impossible to get something like Atomos working for AEM. Certainly it should work for Sling. When it comes to native compilation, though, I mean, there's two things. It's work because you have to, no matter what you do, as I said, give those reflection hints. Okay, so what happens is that they remove all the metadata about classes and methods and stuff like that, and so you cannot do reflection at runtime unless you tell them to retain some of it that you need, right? So you have to basically go through and find out the ones you're missing. So that's still something that would need to be done. to get to work. And the other thing, obviously, is you cannot do a compilation or add bytecode at runtime, right? So, and actually, that's part of, or at least side motivation of what Radu and I did all those years to create those precompiled bundle scripts, was that we thought, well, with those, we have the bytecode precompiled. So technically, it should be possible to be able to run server-side rendered scripts in a native image. And I really want to try it and see how far I get with that. But to be honest, I didn't have time yet to really get this to work. But I think it should be possible. It just is some more work to get there. As you could see, at least we get the web console and all of that part working. It really is a question to attack the script part, the server-side script part of Sling.
Okay. Are there any more questions? I only see the 3 that are answered now. I guess we could go back to the first one that Robert asked about. What is the relation between the ready service thing and the existing Felix system ready and health check modules? I already kind of tried to answer that in the chat, although I didn't have that much text I couldn't fill in more than what I did. Basically, the condition service, the new specification, is only within the framework, and it's really only a marker server. So whenever your code decides that it's ready, it registers that service. Now I think the Felix system ready is more like a remote ready service. If I don't really know it that well, but it could definitely implement this condition service by registering that service when it decides that it's ready. But I think there's also a remote part to the Felix system ready that basically responds to remote calls to, for example, for Kubernetes. I think that part is not really covered under the condition service because it's a local service, unless you make it a remote service. But I think the first thing that it could do is simply register that service when it decides that the system is ready and that it would already be compliant for consumers within the framework.
Yeah, I think the condition service really attacks a very specific use case, right? I mean, it is about the question: is my service right now supposed to be active or not, right? And you can do that with the configuration, obviously, but it is something is missing there. So they could interact, but they're not the same thing to the.
They're not the same thing. Yeah, between the Felix one addresses a different use case.
Yes. That's a good summary.
Any more questions? I guess not. So I guess thanks for your attention, everybody. If you have any questions afterwards, just send us a mail. And enjoy the rest of your conference today and tomorrow and the day after.
Thank you.
Thank you.
Okay. Bye.
Bye.